Well, I would say first, if I just think in terms of the framework of evolution by natural selection, just the logical framework of that theory, what that theory entails is that it assumes that there's an objective reality. It assumes that there are organisms that are being shaped with sensory systems. And the theory then says that it's a theorem of that theory that the sensory systems will not ever reveal true structures of that objective reality. Instead, they will give you sensory systems that serve only as guides to adaptive behavior. So you're not, the whole point is not to see the truth. The whole point is to stay alive long enough to reproduce. That's the structure of evolutionary theory. So once you understand that sensory systems are not windows on the truth, they're merely guides to adaptive behavior. Then I say, well, people then ask, well, how could that possibly be? Help me understand. And I think that's when the metaphor of a virtual reality headset or a user interface on your laptop, those are the kinds of metaphors I think help us to understand what the mathematics of evolution is telling us. Like when you use your laptop, you're writing a paper or a book or something like that, and the icon for the book on your desktop is blue and rectangular in the middle of your screen. It doesn't mean that the book in the computer is blue and rectangular in the middle of your computer somehow. I mean, there's no mapping like that between your senses and the objective reality. Instead, what you see on your laptop hides the truth. And that's why it's valuable. You don't want to see the voltages and magnetic fields and the circuits and software. I mean, if you had to toggle voltages to write your book, good luck. You'd never finish your book. And so that's what evolution did. It gives us a user interface. Now that part is, now I'm just using a metaphor, I mean, for what evolution has given us, but it's given us a user interface that hides the truth, but lets us control the truth, whatever that truth might be, in a simple way, using simple user interface icons.
But the bottom line is Clubhouse acts as a filter in a certain sense. And it is almost as important what information we choose to discard as the information that we choose to get past the filter. And so you're arguing that evolution has designed adaptive filters. We call them PID, proportional integral derivative, feedback circuits, etc. But there's always a lossiness to any filtration system. And I wonder, in the evolutionary framework, there are some things that it's clear that we derive pleasure from them, but it's not clear that it's a fitness boosting as a metric. For example, music. When I'm listening to music, I'm perceiving there's tons of things that are going on, and I smell a smell that might be more easy to see what the purpose is, because maybe it reminds me that it's dangerous to ingest that. But where there's music, where it doesn't seem like there's a fitness payoff in the human, I agree, in birds and whales, probably. I don't know. I'm not a biologist. But the point is, what is the purpose, evolutionarily speaking, of this most august, kind of trait of the human species, to make music for no purpose whatsoever? It seemed biologically wasteful, at least from a novice perspective like mine.
Right. So evolutionary psychologists have thought a lot about this. Steven Pinker has got some good ideas. He calls music auditory cheesecake. It's something that cheesecake sort of hits our senses in a very, very strong way. All the positive things, right? We, in some sense, in the case of taste, we fatty foods are really good for us. They have high calories. Sugary foods are really good for us. We need the energy and so forth. And during the Pleistocene, it was hard for us to get these things. And so if we find a food like cheesecake that has all of them, you'd never find perhaps cheesecake during the Pleistocene, but now that we can make it, it hits all the things that were shaped by evolution during the Pleistocene. And so we go for it. So in the case of auditory stuff, we do use auditory information to tell us, for example, who's attractive. Some people's voices are more attractive than others, and that will have some correlation with the reproductive fitness of that person. The voice of a 99-year-old has certain qualities to it that are different from the voice of a 21-year-old. And we pick up on those qualities, and we can infer something about the age of the person. And that, in terms of reproductive potential, then leads to certain attraction or not. And so those kinds of arguments can be given for why we find certain patterns of auditory stimulation more attractive than others, because they, in the past and in the present, are correlated with reproductive potential and fitness enhancement. So in music now, what happens is, just like with cheesecake, someone figures out how to put all these wonderful ingredients together, and you get something that you would never perhaps ever heard in nature, but now it's like cheesecake, which would never exist in nature until we put all these ingredients together. So that may be one aspect of it, but there may be more also to music in the sense of a social, joint, cooperative and bonding experience that comes from music. So again, tribes in our evolutionary past, often when they went out to hunt or fight, would have some kind of chanting or music together. So it could be a bonding thing. So I would say that from an evolutionary point of view, from evolutionary psychology, the kind of question that you asked, Brian, is a non-trivial one, but we have ideas about how to try to come to rigorous answers.
Mm-hmm.
And I would say my own attitude is I certainly agree that we don't see reality as it is, that our beliefs are not necessarily the truth. And I take that as a welcome wake up. I don't find it discouraging at all. It's a wonderful realization. It's like someone that's had a VR headset on all their life, and they thought that the virtual world that they were in was the fundamental reality, and you finally tell them, you know what, everything that you've seen is just a virtual reality headset, and I'm about to take the headset off. Well, that's good news. So science has the tools to try to go beyond just what our senses tell us. And so I think that we can never know if we've succeeded, but we don't have to give up. So I think this is a fabulous time, actually, in the sciences. Science, I would say, from this point of view, from an evolutionary point of view, since Galileo, we've been sharpening our tools by understanding our headset. So we've really learned how to use experimental and mathematical tools. We've studied our headset. We really have done it so well that our theories are now so good. Evolution by natural selection, quantum field theory, and gravity are so good that they tell us space-time is not fundamental. They're telling us you've been studying the headset. That's an incredible vindication of science. It's telling us that even though you assumed that you were looking at the truth, you're not. You're just looking at a headset. But now use those same tools to try to come up with theories beyond space and time. And the way that you test those ideas is to make them mathematically precise. So like what Nima is doing with his structures outside of space-time, like the amplituhedron or something like that, make them mathematically rigorous, show exactly how they project into space-time, and see the predictions that they make there. And if you can, then you can test them. You only see things in your headset, so that's where the experiments have to be done, in your headset. But you can still test models outside the headset as long as you have a mathematical model about how they project into the headset. So that's what science is now going to be up to. We're taking our first forays out of our headset, out of space and time, and science is up to the task. So this is, for me, an exciting opportunity and not a time to be discouraged. Well, so the answer is I don't know, but I can just tell you how I'm thinking about this. In cognitive neuroscience, we have this problem of consciousness. We call it the hard problem of consciousness, which is how our experience of, taste of chocolate, smell of garlic, sound of a trumpet, are these conscious experiences related to neural activity in the brain, or perhaps to circuits and software in an AI system? And we've come up empty trying to start with the physical systems and boot up consciousness. We've just come up empty. We can't, I mean, I'm not saying we can't do it, but we've had very, very bright people, including Nobel Prize winners, many of them, working on this, and we've come up empty so far. And it seems to me to be principled that we can't start with space-time and matter and boot up consciousness. And so there's two responses. One is to say, well, there's no such thing as consciousness. It's just an illusion. So Dan Dennett and Keith Frankish will say this. And of course, then they have to explain how the illusion of consciousness arises, right? So what is the brain activity that causes the illusion of the taste of vanilla? So there is no such thing as the conscious experience of the taste of vanilla, but nevertheless, somehow our brain has duped us into having the illusion of the taste of vanilla. So they still owe us a mathematically precise theory about what are the neural processes precisely that lead to the illusion of the taste of vanilla, and why those processes could not be the illusion of the sound of a trumpet. So, and there's nothing there yet. But there's the other approach I'm taking, now to get to your question. I don't view consciousness as a filter, but I'm saying if I don't start with space, time, and matter, maybe I can start with consciousness, not as an emergent property of space, time, but as an entity that I want to mathematically model on its own terms. So I want a simple mathematical structure that I claim captures everything there is to capture fundamentally about consciousness. And I want to look then at the mathematical implications of that formalism, and then show that somehow there's this dynamics of consciousness, and that can give rise to space-time. So space-time is not fundamental in any sense, and scale structure in space-time is in no way fundamental to consciousness. That consciousness itself is fundamental. My attitude is very much like Turing when he was trying to come up with a theory of computation, right? Computation is a wild and woolly enterprise. There's traveling salesman problem, computing pi, there's NP-complete problem. There's tons of stuff in computation. Turing managed to find this drop-dead trivial formalism. A finite set of states, a halt state, start state, a set of transition rules, and that turned out to be enough to have the Church-Turing thesis. Anything that's computable can be computed by a Turing machine. I want the same thing for consciousness, a minimal formalism that has combinatorial properties that can allow me to build a theory of anything that I want to have about consciousness, the self, learning, memory, problem solving, intelligence. I want to build all those things from a stripped down version of consciousness. So that's the attitude in which I'm thinking about it. Consciousness, from this point of view, isn't like just a filter, it's the whole thing. Now, again, I'm probably wrong, but I'm just telling you the strategy that I'm taking. I don't want to start with space, time, and matter because that doesn't seem to work. So let me start with consciousness and see if I can boot that up.